All right, thank you, Mikhail, for the introduction. Yeah, like he said, my name's Andrew. I'm the cloud services lead at Gatsby. Has anyone here used Gatsby before? Oh, right on, cool. Hopefully everyone likes it and doesn't hate it. Well, cool. So I guess a little bit about what I'm working on. A lot of people use Gatsby for like basic sites, especially things like cover letters or resumes or personal blogs and the like. But a lot of larger companies, I can't really drop any names, but there are several large companies that are interested in using Gatsby on a much larger scale, and that's kind of what we're targeting our monetization model around. So how do you build Gatsby, like a Gatsby site with 1 million+ pages without it taking 5 hours, right? So a little bit about the project I've been working on. Basically Gatsby Cloud will be an entire preview, build, and deployment pipeline for Gatsby. Everything from like when you create a branch on GitHub, you get a preview instance that people can interact with as people change the CMS, like Contentful or whatever CMS provider you're using. When you're ready to deploy, it runs a full build, pushes it to a cloud CDN and validates cache. So basically all of the ops stuff you'd usually have to set up for a Gatsby site will just work out of the box for you. So you can think of it as like a specialized CI server for Gatsby. So obviously with a 1 million-page site, which is kind of what we're hoping to target, you need distributed rendering. You can't render everything on one Node.js process. You have to distribute it across hundreds of processes, which means you have to orchestrate well. You have to, Gatsby also does asset post-processing like image compression and effects, all with your GraphQL query. So distributing that is also slightly painful. You can't do that on one process, on one machine. You want to be able to distribute that across n number of machines elastically. Also site analysis, so SEO scoring and lighthouse assessments on every build. There's a lot of stuff that we want to add to this, and it's super difficult to solve in a sort of a traditional SaaS CRUD API approach, where you have like a monolithic service that does everything. You really can't. So we are using a technique called event sourcing. And what event sourcing is basically treating, I'm trying to think of a good synonym. I guess it's like distributed Redux on the server. So you have a sort of queue that you push actions into, and then you have a bunch of workers that react to those actions and do certain things. With this kind of system, you kind of have to embrace eventual consistency, meaning that when you perform a write, it doesn't immediately make it into the database. The intent to make it into the database is stored in the queue, and it will eventually make it into the database, and all of the different reactions will eventually happen, but you can't immediately read. So we've had to we're having to rely heavily on GraphQL subscriptions to actually make a normal user experience for, for this type of problem. So a little bit about the Gatsby Cloud Architecture. It's written in JavaScript, Golang, and C. We're having to do pretty deep integration with Kubernetes, Docker, and hypervisor/hyperd. All new state, including error state, is actually streamed via GraphQL subscriptions. So if you run a query, you're pulling data out of Redis, Elasticsearch, or Neo4j, or whatever aggregate stores we're dealing with. But if you do a mutation, you're actually waiting for the response to come back via a stream. And that could be an error, or it could be like a result, whatever. The architecture around this is all unidirectional, kind of like Flux, in that when you write a mutation, it kind of cycles around through your reactors and other components that I'll talk about in a moment. And there are 4 primary components. There are API components, Reactor components, reducers, and aggregators. And yeah, I think, so this talk is kind of like how we're using subscriptions to solve this problem. It's not so much how to make subscriptions easier. Just a little bit of clarification. So the first time a component we decided to sort of use for all of like user-facing interactions is something called an API, and I think that's self-explanatory. Basically, you have write and read operations. So write operations dump an action into Kafka, just like you would dispatch an action in a React app. And read operations pull directly from our aggregate stores. Aggregate store is basically like pre-created views that we ahead of time create and stuff into Redis and Elasticsearch and other places so that load times are really fast. Also, APIs can optionally subscribe to aggregator components. What that means is that all of our data that the user interacts with is real time out of the box. So every single time a piece of data changes, there's always an event that goes out, and that can always be hooked up to a subscription. So Reactor components are the second type of component we build on the back end. They're akin to like Redux middleware. So basically, any type of sort of side effect you'd want to apply, like when you create, like for instance, if a user signs up through Auth0, so they go through an SSO flow with GitHub, the front end sends the Auth0 token to the back end. We dump an action into Kafka with that token, and then our Auth0 reactor would then fetch the entire user object from Auth0's API, and then flush that down the pipe, just like you would do with like Redux middleware, for instance. You can intercept the action, do something else like a side effect, and then reapply. So things like creating containers for builds. So like if you push a git commit, we have to actually manually hit Kubernetes API to spin up a container on an untrusted cluster with Hyper-D and all this other crap. But basically, all of that logic to actually integrate with Kubernetes lives in a Reactor service designed specifically to integrate with Kubernetes. And obviously, these are impure functions. Reducer components are a little different. They're just like Redux reducers. So basically, when, for instance, if I signed up and the Auth0 reactor fetches my user object from Auth0 via the SSO flow, we actually want to save that in the database. So the user reactor would receive a action called like user create that would look for existing state in the database, which in this case wouldn't exist. So it would perform an insert into Postgres, and then it would emit an event saying, okay, there's new data available. In the same way you could do like redux.subscribe. So aggregator components actually subscribe to the output of reducers, and they basically load data out of our general store, which is Postgres, and they load them into, and loads it into aggregate stores. So this is sort of like an ETL process. So any sort of view that we're going to need on the front end of data that we need quick access to, we ahead of time sort of load that into Elasticsearch and Redis so that when the user accesses a page or runs a query, it's near instantaneous. Like it's just loading it out of Redis, or if we need search, it loads it out of Elasticsearch. So I kind of already went over this a little bit. How am I doing on time? Oh, cool. Yeah. So a good scenario to kind of understand this system, it would just user sign up, what we've already been talking about. So a user steps through GitHub SSO auth flow through Auth0. So that's one of the ways that people will log in with Gatsby Cloud once we go generally available. The web app submits the Auth0 token via GraphQL mutation. The GraphQL server dispatches an action via Kafka containing the Auth0 token. The user reducer takes the user ID from the token, that's all we have so far, and inserts it into the general store, Postgres. So it creates a row in Postgres that just has that Auth0 token ID in it. Then our Auth0 reactor reacts to the user reducer's, like I created something event, and goes and fetches the actual user object from Auth0 and dispatches a new action containing the full value of the user. At that point, the user reducer would run again because it's receiving another action that acts upon a user, and it's going to reduce that full value into the existing row it had already created. Then our aggregator would pick up on the actual user, load it into Redis, Elasticsearch, whatever else, and obviously that would trigger a GraphQL subscription event because the GraphQL server is subscribing to the aggregator event. So as things are loaded into Redis and as things are loaded into Elasticsearch, GraphQL is aware of those changes happening, so it makes subscriptions super trivial. And adding new product requirements with this flow, this is actually the reason we chose this, both because we need like insane amount of scale, given that a single build will output about 5 megs worth of text, and we have to be able to stream those logs to the user in a variety of different places. It's also very flexible for new product requirements. So if we wanted to send user data to Salesforce, and we were like, okay, we need to do this, all we have to do is plug in a new reactor. And subscribe to the existing stream of messages, fetch data, or every time a user is created or updated, we just post the object over to the Salesforce API, and now our sales team is kept in sync with signups. Or if we wanted to send them a welcome email, we could do the same thing with a reactor that integrates with SendGrid and renders welcome emails, right? So it's a very flexible pattern, and it's one that we're pretty happy with so far. So yeah, we are aiming for general availability of Gatsby Cloud by the end of Q4, beginning of Q1. Obviously follow GatsbyJS on Twitter if you're interested. And we'll be writing more content that goes more into depth as to how you can build things. We've actually built a couple of in-house frameworks that makes this really simple to work with. So yeah, stay tuned.